Okay, I wanted to make a video doing some implicit differentiation practice. So here's an example. So a common example might be we have a relationship between y and x. It's something like maybe y to the fifth plus 3x squared y squared plus 5x to the fourth equals 12. And the basic idea is that we want to take the derivative of both sides. And we're going to take the derivative with respect to x. And one thing you just have to remember is that, well, the derivative of x, well, we're used to doing things like that. But when we take the derivative with respect to x of the letter y, we have to use the chain rule. Right? So I'll sort of talk through what I mean there. So let's take the derivative of both sides. On the right-hand side, well, the derivative of 12 is going to be 0. Now, what's the derivative of y to the fifth? Well, the derivative should be 5y to the fourth times that correction factor. Remember, we don't know what function y is. If we tried to solve for y, it'd be a complicated function of x. But the chain rule says that the derivative of y to the fifth is just going to be 5y to the fourth times whatever y prime is. Okay. So that's our first term. I'm going to actually make some space for our equals 0. What about this middle term here? Well, this looks like a product. It looks like we have 3x squared times y squared. So let's say to take the derivative of that, we'd want to use our method with the 4 parentheses here. So let's write that out. So that'd be 3x squared derivative y squared, and then 3x squared times y squared derivative. And then finally our last term, this 5x to the fourth, well, that we can just use the power rule. That's 3x, that's 20x cubed. Right? So let's keep going. We've got some derivatives left to simplify. So let's rewrite this expression. So we've got here 5y to the fourth times the derivative of y. And then we've got, okay, what's the derivative of 3x squared? That's 6x. And multiply that by y squared. And then I multiply this by 3x squared. And now we get another derivative. Well, this is kind of like the y to the fifth term we did earlier. The derivative of y squared, well, the power rule says it should be 2y. And the chain rule says that we have to multiply by a correction of whatever the derivative of y is. Okay? So now we've got this nice expression here. And what I want to point out, maybe I'll do it in a different color, is that we have exactly 2 terms that have a y prime in them. Okay? So let's try to get all those terms on one side of the equation. So let's do 5y to the fourth y prime plus 6x squared y times y prime. So that's these 2 terms here. And then let's get this other term on the other side of the equation. So it's going to be minus 6x y squared. And now we can factor out a y prime. So let's factor out a y prime from the left-hand side. So we get 5y to the fourth plus 6x squared y. And that's going to equal minus 6y squared. And then let me just copy this to my next page. This is our last expression. And now I'm just going to solve for y prime. So y prime is going to be minus 6y squared over 5 times y to the fourth plus 6x squared y. Okay. So this is